Everybody, questions. He says questions are on screen for you now. There you go. Okay, I'm going to try and whiz through them a little bit quicker today. I think the time I'm spending explaining them to you is what's causing the problem with this screen not being captured correctly. So I'm going to give you obviously a chance to calculate them yourself, and then I'm going to try and speed through the answers a little bit more. Okay, so it's not me just rushing through because I've got better things to do. I'm hoping that will solve the problem that we had yesterday. Okay, so you've got a chance to pause the video there if you want to have a go. Excuse me. You want to have a go before me? If not, you can have a go alongside me. So I'm going to follow the same principle. I'm going to try and do things mentally wherever possible, break the question down and not use a formal method. It hasn't asked me to, so I want to try and do them mentally. These are supposed to be mental starters. So I've got 233 times 5 as my first question. 15, 150, 2 times 5 is 10, so that'll be 1,000. Okay, add them together, 1,165. And again, you could have used column addition for that, but I mean, that one is going to end up in this column, that 5 will end up there, that 1 will end up, and so on and so on. So there's no carrying this, there's nothing to worry about. It's quite an easy question in terms of the adding, so I don't need to worry about that. 345 divided by 100. So you've got hundreds, tens, units, and you've got tenths, hundreds, and thousands. Okay, so you've got 3, 4, 5. If you're divided by 100, everything's going to move 2 place value columns to the right. So the 5 in the units will go 1, 2, so it'll become there. So then you've got 5, 4, decimal point 3. Okay, so your hundreds will go 1, 2, and end up in your units. So it's 3.45. The times looks a little bit funny on this one. I'm not sure why. 456 times 3. It looks like it's an X. It looks like it's trying to give you algebra, but it's not. 6 times 3 is 18. 5 times 3 is 15. 150. 4 times 2 is 12, so that's 1,200. So 1, 3, 6, 8. Perfect. Okay, so 1,368 for number 3. Factors to 45. Put it there. Again, we've done factors to death now. 1 and 45. 2 and nothing. So I'm just going to put 2 there. 3 will. It's 15. Unless I'm mistaken. 15, 30, 45 here. 4 won't. 5 will. 5 times 9. 6 won't. No. 7, no. 8, no. So 9. Let me just check I've got all those. Yeah, just looks like there should be more, doesn't it? So again, 9 is a factor, but I've already got it on this side, so I've reached what I've called this here the tipping point. It means I've got more, okay, by pairing them up. Okay. 3/8 of 24. Oops, not writing. Should be 3/8 of 24. By now, divide by the bottom times by the top. So 24 divided by 8 is 3. 3 times 3 is 9. And that's it. Have I got that right? Yeah. Just loads of working out on the answer there. I was a bit worried. Yeah, so the 3 comes from, this 3 comes from 24 divided by 8. And then you take that 3 and you multiply it by the numerator, which just also happens to be 3 in this case. Okay, that's that's the one that we've got the funny dance for. But you'll notice now how much you're needing to use it. So it's definitely worth remembering. Sorry, all stuff on my screen. 7/3 simplify. Okay, now in previous days I've drawn pictures and so on to show you this one. If you're struggling, I would draw a bar, split it into 3, draw a couple of bars, and then colour in 7 pieces and see how many you've got. When it says simplify, it wants you to give it from an improper fraction here to a mixed number, which we'll do down here. Okay, so counting 3s, get to as close to 7 as you can, is 6, which is 2 groups, so I can get 2 whole groups of 3 out of 7, and then I've got 1/7 left over. Okay, again, think about it in terms of pieces of cake, pieces of pie, pieces of chocolate, whatever. 3 pieces makes a whole, and you've eaten 7 pieces, you've eaten 2 wholes, and then you've eaten a 7th as well. Freezer is -12, the fridge is 2 degrees, what is the difference? Okay, fridge is 2, freezer -12, difference of 14. Jump a 12 to get to 0, jump a 2, so 12 add 2 is 14. Okay, not a difference of minus 14, it's a difference of just 14. Okay, and last one, that was nice and quick. 4, 5, 6, 7 divided by 1,000. Okay. Yeah. Okay. We've already done divided by 100. So we need thousands, hundreds, tens. Well, you probably don't, but just for the purpose of explaining. Then you've got tenths, hundreds, and thousands. Okay. So you've got 7, 6, 4. And then you divide it by 1,000. Divided by 10 moves once, divided by 100 moves twice, so divided by 1,000 moves 3 times. Okay. Worth remembering as well, it's not how I would recommend teaching it or learning it, but there's 3 zeros in 1,000 and you're moving 3 place value columns. Okay, so that's a nice way to check, I suppose. Divided by 1,000. So take the units, tens, 100, 1,000. Or tenths, hundreds, thousands. What I was saying there was divided by 10, divided by 100, divided by 1,000. So your units, your 7, is suddenly in the thousandth column, which means 6 will be in the hundreds, your 5 will be in the tenths, and your 4 will now be in the units. So it's 4.567. Okay. Right, as usual, I will stop the video here. I'll put a challenge question up for you. Have a go at the question, then I'll come back and then I'll explain how I would have done the challenge question and I'll give you the answer. Okay, like I said, a bit of a quicker one today, but it's not anything beyond me trying to make sure you can see all the working out, because it's not much point if you only see sort of me blabbering away and then 30 seconds everything appears. So I'm hoping by rushing through them a little bit more today, you still understand what we're doing, because we've talked through the methods already on these videos. So now I'm just showing you how to do them quickly without re-explaining myself every day. And hopefully it fixes the problem as well. So I'll see you in a second for your challenge. Yeah, and I don't know what else I was going to say there. I will see you in a minute for your challenge. Okay, so you've had a look at the challenge question by now, and I've put it up on the screen for you as well as usual. So as normal, I haven't had a go at it myself. I've got the answer in front of me, but obviously I need to make sure that I reach that answer. So I'll have a read through of it with you, and then we'll start wherever we can. Dale is thinking of a decimal number. The ones digit is less than 1. The tenths digit is an even number between 0 and 5, but it is not a prime number. The hundredth digit is double the tenth digit. The thousandth digit is a square number between 5 and 10. And then at the end, he converts his decimal number to a fraction. What is Dale's fraction? So there's loads of steps to do on that one. Loads and loads and loads. Okay, so first thing I'll do is get my boxes drawn in just like he has. Excuse me. So the first thing that I need to do is find the decimal number, and then I can convert the decimal number into a fraction, but I'm not there yet. So first thing that I noticed is this: the ones digit is less than 1. Well, less than 1 is obviously 0. The tenths digit is an even number between 0 and 5, but it is not a prime number. So your choices are 1, 2, 3, 5. You've only got 2 and 4 that are even, and 2 is a prime number, so it must be 4. The hundredth digit is double the tenth digit, well that must be 8. And the thousandth digit is a square number between 5 and 10. So you've got 6, 7, 8, or 9. Possibly 9 and 10 as well. Depends on the word in the question. I always struggle with between. But for me, I would go for those initially and see if anything fits. And then if it doesn't, then maybe incorporate 5 and 10 in there. Okay, so you're looking for a square number. Square number is something times by itself that will reach one of these. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. It's that one then, isn't it? 9. So you've got 0.489. I'm just going to clear everything away because I need some more working out now. So you've got 0.489. Okay. Yeah, sorry. So now I need to put it over a fraction. If I put it over 100, I'm going to end up with either 489 over 100, which obviously doesn't make any sense because I haven't got a whole here. Look, I've got nothing in the ones, but 489 over 100 means I've got 4 holes, 4 ones, so that's not right. It could be 48.9 over 100, but you don't use decimals in a fraction, so that doesn't work either. Okay, 48.9 over 100 would technically work, but it's not correct. So I'm facing a bit of an issue here. The solution to the issue is to not put the fraction over 100. Okay, we can either put it over 10, we can put it over 100, or we can put it over 1,000. Over 10 isn't going to work. 4 over 10, well, 4.89 over 10. We've still got that decimal point, so that's out. We've tried 100. It's a good noise, I like that noise. So it must be this one. 489 over 1,000 gives you 0.489 when you convert it back to a decimal. Correct answer. So it's this one. He converts his decimal number to a fraction. What is Dale's fraction? This you don't need to worry about. That is for the putting it into the software. You don't need to put the slash like that. You can put it like I've done there. That's absolutely fine. So the answer is, let's just check here, 489 over 1,000, or you can put the comma in there, as you may well have done. Okay, so cheers. Thanks for joining me on my wonderful maths adventure. I will see you tomorrow. I don't even know what day of the week it is anymore. I'll see you tomorrow. Bye.